Hello, welcome to this video on AI model types, their features and applications. In this video, we will discuss the various AI model types, GANs, VAEs, autoregressive models, diffusion models, flow-based models, and what is meant by retrieval augmented generation. And so in GANs are those, let's go back, generative adversarial networks. So their key features include two competing neural networks which generate and discriminate. The generator learns to create realistic data, while the discriminator learns to distinguish real from fake. This adversarial training process continually improves both networks, but it can be challenging to train and to achieve stable results. And so this is an example of a chart of what that might look like. As we can see, we have a generator. It can generate fake samples, which goes into if it's correct, and then we fine tune what we're doing. GANs get applied in a few different ways. They get applied in image generation for faces, landscapes, and objects, text generation, including poems, code, and script, video generation, such as realistic videos and animation. They also say it's good for drug discovery, where it can generate molecules with intended properties. I'm not entirely sold on this. There is evidence that this doesn't work, but you can read more about that in a different video, different module. And music generation, so it can compose new songs. So we've seen some of that in some of these GPT models that have come out. So a variational autoencoder, which is a VAE, its key features include that it can encode input data into a lower dimensional latent space. It can learn a probability distribution over that latent space. It can decode samples from the latent space to generate new data points, and it focuses on learning meaningful representation of the data. And so this might look like something like this. So if this was the chart, this is very, it seems a little complex. So those of us, again, who are not computer scientists, just know it kind of goes through this multivariate, diagonal multivariate Gaussian model, and it reconstructs that data on the other end. These things are good for image compression, so it can efficiently store and transmit images, anomaly detection, where it can identify unusual data points, dimensionality reduction, where it can compress high dimensional data, and it can do the text summarization, so generate concise summaries of textual documents. So those autoregressive models, their key features include generate data points point by point, conditioned on previously generated points, can use recurrent neural networks or transformers to capture long-term dependencies. It can be computationally expensive, though, for long sequences. So if you're doing something that has a lot of data, this might not be a model you want to use. But what they are really, really good for is predicting things, and they get used a lot in several different arenas, but this is what an output might look like from one. And so these models get used in, again, text generation, where it can produce realistic and coherent text sequences, music generation, where it can follow genre and style, but it really does well at time series forecasting, so predicting future values of a time. And then it can do image in-painting as well, such as filling in the missing parts of an image. Diffusion models, their key feature includes starting with a simple noise and gradually denoising it into realistic data. They use a U-Net architecture with skip connections to preserve information. And it can be more stable and easier to train than a GAN, but often slower. And so diffusion models might do something like this, right? So we take an image and then we denoise it, and hopefully we get a better image at the end. So again, their applications get used in high quality and diverse images. We get coherent and grammatically correct text from them. It can do realistic and musical audio as well. And again, with their inpainting and denoising, improving the quality of images or audio. Flow-based models, their key features include transforming a simple distribution into a complex one using invertible transformations. We learn the parameters of these transformations from the data, and they can be efficient and accurate for high dimensional data, but again, training them can be challenging. So they're really good, again, for image generation, where they do realistic and diverse images. They model the probability of the distribution of data. They can compress high dimensional data and identify, again, unusual data points. So many of these models do the similar things. Some use a little bit more power than others. Some are better than others. It depends upon what's happening. So here's another little chart that kind of talks about the different models and how they get charted out. And here is the last chart here is from IBM's Coursera. There is a course on Coursera where I borrowed much of this video's content. But this chart talks about the features where it's like the data type, task, objective, quality of samples, control over the generation, training complexity, and if it's interpretable. And then the different models are listed at the top. So GANs, VAEs, autoregressive models, diffusion models, and flow-based models. So I have linked to a document, PDF in our module for today that includes both charts. So there's a chart for what we just went through and a chart, this specific chart as well. Lastly, I want to discuss RAGs. So these are the retrieval augmented generations. And what these do is they are a type of information retrieval process. I borrowed this again from Wikipedia. It modifies the interactions from a large language model so that it responds to queries with reference to a specified set of documents, which uses it in preference to information drawn on from its vast statistical training data. So these are the things that are getting used in our databases. So when we think about how it might get used in something like Scopus or Web of Science, these RAGs are what is being used for the particular documents in that database, and then hopefully it pulls back that information from only those documents in that database. So according to the Wikipedia document here, it also talks about how this allows these LLMs to use domain-specific and/or updated information. These use cases can include providing chatbot access to internal company data or giving factual information only from an authoritarian source. And so again, here's another little chart of what that might look like if we're charting out how these things work. Okay, so this was a very brief video on all those different definitions. I'm not expecting anyone here to be able to rattle those definitions off, but just understand that computer scientists use a couple different models to be able to do the things that they do with AI and the products that we might be looking at. So it may be helpful to know what a RAG is. It may be helpful to know if a database is using a flow-based model and a RAG to be able to get their generated text to you.